Hello there today, we're diving into the world of digital twins and how they're causing quite a stir in the automotive industry. Imagine being able to predict vehicle failures before they happen, optimize electric vehicle battery performance and test autonomous driving algorithms in a completely virtual environment, all without ever touching a physical car. This is the power of digital twins in the automotive industry. In this video, we'll explore how digital twins are transforming vehicle engineering, using a real-world case study to showcase the game-changing impact of this technology. What is a digital twin? So, what exactly is a digital twin? A digital twin is a virtual replica of a physical vehicle or system. It continuously receives real-world data from vehicle sensors, telematics, and cloud platforms, allowing engineers to simulate, analyze, and optimize performance in real time. It's a dynamic, data-driven model that mirrors the physical vehicle throughout its entire life cycle, from the drawing board to the scrapyard. These digital twins are like magic mirrors for engineers, offering unprecedented insights into a vehicle's performance, predicting potential issues before they even arise, and enabling innovations that were once the stuff of science fiction. In simple terms, digital twins are revolutionizing how we design, manufacture, operate, and even drive cars. So, put on your learning goggles because we're about to explore this groundbreaking technology and its impact on the future of automobiles. Let's look at a real-world example. Optimizing EV battery performance with digital twins. The challenge? Battery degradation over time, inefficient thermal management, inconsistent charging cycles reducing battery life. What's under the hood of this virtual marvel? Well, let's pop the bonnet and have a look, shall we? At its core, a vehicle digital twin is a sophisticated software model fueled by a constant stream of data. This data comes from various sources, like sensors embedded in the physical car, real-time traffic information, and even historical performance records. It's like having a car that constantly reports back on its every move and inner working. This data is then processed and analyzed using powerful tools like artificial intelligence and machine learning. These clever algorithms help the digital twin learn and adapt, becoming smarter and more accurate over time. It's like teaching an old dog new tricks, except this dog is made of data and can predict the future. But it's not just about data and algorithms. A digital twin also includes a visual representation of the vehicle, often in stunning three-dimensional detail. This allows engineers to interact with the virtual car, rotate it, zoom in on specific parts, and even simulate different scenarios. Imagine playing a video game, except you're designing and testing a real car in a virtual world. So there you have it. Data, algorithms, and a virtual replica. These are the key components that make a vehicle digital twin the powerful tool it is. Now let's see who's putting these digital wonders to good use. From the first combustion engine to the rise of electric vehicles, car makers have always been at the forefront of technological advancements. And now, digital twins are the talk of the town. Original equipment manufacturers are among the early adopters, using digital twins to streamline their design and manufacturing processes. Imagine being able to test different car designs in a virtual wind tunnel, optimizing aerodynamics without building a single physical prototype. That's the power of digital twins. But it's not just the big car makers who are benefiting. Fleet managers are using digital twins to track their vehicles in real time, optimize routes, and even predict maintenance needs before a breakdown occurs. It's like having a crystal ball that tells you when your lorry needs a new set of tires. And let's not forget the electric vehicle revolution. Electric vehicle manufacturers are leveraging digital twins to optimize battery performance, extend range, and even develop faster charging solutions. It's like giving an electric car a brain boost, making it smarter and more efficient. Even the pioneers of autonomous driving are jumping on the digital twin bandwagon. They're using these virtual replicas to train self-driving algorithms in safe, controlled environments, simulating millions of miles of driving without ever hitting the open road. It's like giving a self-driving car a crash course in driving without the risk of actual crashes. From design and manufacturing to fleet management and autonomous driving, digital twins are transforming the automotive industry. And as this technology continues to evolve, we can expect even more exciting applications in the years to come. EV battery optimization, a digital twin case study. Now let's dive deeper into a specific use case where digital twins are making a real difference. Electric vehicle battery optimization. As you know, the battery is the heart of an EV, and its performance directly impacts the car's range, lifespan, and overall driving experience. One of the biggest challenges with EV batteries is managing their temperature. Overheating can significantly reduce battery life and even pose safety risks. That's where digital twins come in. By simulating the battery's thermal behavior under different driving conditions, engineers can identify potential hotspots and optimize cooling systems for optimal performance. Another challenge is maximizing the battery's range. Using real-time data from the vehicle's sensors, the digital twin can analyze driving patterns, road conditions, and even weather forecasts to predict energy consumption and suggest the most efficient routes. It's like having a co-pilot who knows exactly how to squeeze the most miles out of every charge. Digital twins are also playing a crucial role in developing faster and more efficient charging solutions. By simulating the charging process and analyzing battery data, engineers can optimize charging protocols, reduce charging times, and extend battery lifespan. It's like giving your electric car a quick energy boost without stressing its batteries. But the benefits don't stop there. By analyzing data from thousands of vehicles, digital twins can help manufacturers identify battery anomalies, predict potential failures, and even issue proactive maintenance alerts. It's like having a team of mechanics constantly monitoring your car's health, ensuring it runs smoothly for years to come. Beyond batteries, digital twins in vehicle design, fleet management, and autonomous driving, the applications of digital twins in the automotive industry extend far beyond just EV battery optimization. They're like versatile tools that can be used in various stages of a vehicle's life cycle, from the drawing board to the open road. In the realm of vehicle design, digital twins are revolutionizing the way cars are conceptualized, prototyped, and tested. Imagine being able to create a virtual wind tunnel to test the aerodynamics of different car designs, or simulate crash tests without putting a single physical car at risk. That's the power of digital twins in action. For fleet managers, digital twins are like having a bird's-eye view of their entire fleet, with real-time insights into each vehicle's location, performance, and maintenance needs. This allows for optimized route planning, reduced downtime, and proactive maintenance, ultimately leading to significant cost savings and increased efficiency. And let's not forget the exciting world of autonomous driving. Digital twins are playing a crucial role in training self-driving algorithms, providing a safe and controlled environment to simulate millions of miles of driving without ever hitting the open road. This allows developers to test and refine their algorithms in various scenarios, improving the safety and reliability of self-driving systems. From streamlining the design process to optimizing fleet operations and accelerating the development of autonomous driving, digital twins are transforming the automotive landscape. And as the technology continues to evolve, we can expect even more innovative applications in the years to come. The future of digital twins in automotive engineering is limitless. AI-powered twins, predicting and preventing system failures in real time. 5G integration, real-time, low-latency data exchange between vehicles and twins. Lifecycle twins, continuous monitoring from production to end-of-life recycling. Smart cities, integration, using vehicle twins to optimize traffic flow and reduce congestion. Digital twins are transforming the automotive industry, enhancing performance, boosting reliability, and reducing costs. What do you think the future of digital twins holds? Let us know in the comments. If you enjoyed this video, hit the like button, subscribe for more tech-driven automotive insights, and turn on notifications so you don't miss our next video. Thanks for watching. For more detailed and informative similar videos, please log on to our website www.ProgNXT.com. or email us at training@ProgNXT.com. Don't forget to hit the like button, subscribe for more tech-driven automotive insights.